We've been using salt and sugar to preserve food from time immemorial. Due to the negative impact of the two, these days companies are interested in adding synthetically produced preservatives like benzoic acid, acetic acid, sorbic acid, sulfites, nitrites, and so on for either preventing or delaying the growth of spoilage organisms in food. This is called as chemical preservation of foods. Since the chemicals are used at concentrations below 0.1%, they do not cause any sort of alteration to the taste or texture of food in which they are added. Preservatives, they are classified as GRAS, meaning they are generally recognized as safe elements or compounds. So, how do we know what preservative to use, in what food, and the dosage level? Just like we have positive lists for irradiation of foods, we have a positive list for preservatives that can be added to foods. They are generally designated by an E number. Now, before looking at some of the commonly used preservatives and understanding the science behind microbial cell death, there are two important assumptions that is common for all preservatives, mostly acid-based preservatives. First one is that the efficiency is much more in salt form due to higher solubility of salt in water. And the second one is the antimicrobial activity is function of percentage of undissociated molecules of acid present. What I mean by that is, in order to explain that, I have to explain you the concept of pKa value. So pKa value of an acid, for instance, let's take preservative sodium benzoate. So pKa value of sodium benzoate is that pH value at which sodium benzoate is completely dissociated into its constituent elements, that is your sodium and benzoate. Above pKa value, the compound is completely dissociated into sodium and benzoate, and below pKa value, the compound is undissociated to varying degree depending on the pH. Therefore, you see that acids generally they are effective at lower pH as the compound is present in its undissociated form. The first acid that's used is benzoic acid. Benzoic acid is used to inhibit yeast and mold in high acid foods like soft drinks, ketchup, and salad dressings. Then we have sorbic acid, which is used as fungal inhibitor in perishable foods like fresh fruits, fresh meat, fresh vegetables, and so on. Finally, we have sulfur dioxide and sulfites, which is used for preservation of items like lemon juice, wines, fruit juices, dried fruits, and so on. Regardless of the preservative that we are using in food, mechanism of action remains the same. It is through something called as proton motive force. Suppose, let's say our food has several microbial cells and we add a preservative, let's say sodium benzoate, to our food system. Then there is a difference in concentration of sodium benzoate present in food and inside the microbial cell. This difference acts as a gradient for movement of sodium benzoate from region of its higher concentration, which is food, to region of its lower concentration, which is the microbial cytoplasm. In the cytoplasm, due to change of pH, sodium benzoate breaks down to its constituent elements, which is your sodium and benzoate molecules. Now, these sodium and benzoate molecules, they interact with various cytoplasmic elements, disrupting the stability of microbial cells, leading to cell death. The major consequence of this proton motive force is that amino acid transport is disrupted, meaning there is an interference with energy production. Thank you for staying with me through the video. In case you have any queries, please feel free to put them in the comment section and I'll get back at the earliest.